This experiment is about measuring tensile force. Before starting the experiment, position the base of the support rod on the table edge and secure it in place by tightening the screw. Stick the support rod into the hole. The experimental setup will look like this. Start by attaching a spring and a ruler to the arm of the support rod. Then measure the spring's original length. The original length of the spring is 7.15 centimeters. Then hang one weight on the end of the spring. The spring's length is now 8.95 centimeters. The elongation is 1.80 centimeters. Then unsling the weight from the spring. We see that the length of the spring is 7.15 centimeters. Repeat the process by hanging two weights on the end of the spring. The resulting length is 10.95 centimeters, which means that the elongation is 3.80 centimeters. Remove the two weights, and the length of the spring returns to 7.15 centimeters. Next, hang three weights. After hanging three weights, we observe that the length of the spring is 12.95 centimeters. The elongation is 5.80 centimeters. Carefully remove the weights. Without the weights, the spring's length returns to 7.15 centimeters. Repeat the same steps using four weights. 1, 2, 3, and 4. We observe that the length of the spring is 14.90 centimeters and the elongation is 7.75 centimeters. After recording the data, unsling the weights. Now observe the length. Without hanging any weight, the spring's length returns back to 7.15 centimeters. Finally, hang 5 weights. 1, 2, 3, 4, and 5. The length of the spring is 16.85 centimeters and the elongation is 9.70 centimeters. After taking the measurement, carefully unsling the weights. When the weights are off, we observe that the length of the spring is 7.15 centimeters. Yes, it is 7.15 centimeters. Record these values on a chart. Then make a plot of elongation versus number of weights.